Today we will be continuing on with exponential functions, both growth and decay. Today's date is 5/18, which means we will be covering exponential functions, as I said earlier. I wrote 5/20, my mistake. 5/18, exponential functions, day 3, part 1. Graphing. Quick recap. So last week we discussed exponential growth and exponential decay. This is what exponential growth functions look like. They have this increasing curve like this. Remember, exponential growth functions and exponential decay functions, or exponential functions in general, are functions in the form of y equals a times b to the x. So for growth, b is going to be greater than 1, and they have, like I said, this increasing curve where the curve gets big kind of quick. And exponential decay functions have this decreasing curve where it gets smaller really quickly. And this is for b is greater than 0 and b is less than 1. That's the difference between the two. Graph the functions. Determine if the function models exponential growth or decay. Then state the y-intercept, the domain, the range, and behavior of the graph. So if we remember last week, we talked about how the domain for exponential functions are go like this, from negative infinity, comma, to infinity, which is essentially all real numbers. Then we have the range, and the range for it would be, it goes from, so first we got to determine what kind of function we got here. So if we take a look at our function, we take a look at our b value, we notice that b is greater than 1, so we know we have a growth function. And we know that the a value is positive, so we know that it is going to go from 0 to infinity. And we know that this could also be rewritten as y is greater than 0, because the values here are bigger than 0. Let's take a shot at graphing this guy. So to do it by hand, you need to gather a couple values. So make a table. So go from -2, -1, 0, 1, 2. We need our calculator. 5 times 1.4 to the -2. I put -2, that's why it issues. That's going to be 2.55. Now let's try the same function, except it's going to be a -1. So now I got 3.57. Or 3 57/100ths. If I try 0, I know that's going to be 5, and I'll show it on the calculator anyway. As you can see, now we'll do 1. It's going to be 7. And then last but not least, x equals 2, get 9.8. Now we're going to plot this guy 0, 5, 1, 7, -1, and 3.57, -2, 0.55, and then we got 2 and 9.8, and we remember that it has this curve. As you can see, this thing goes all the way from negative infinity to positive infinity in terms of the domain. The range, it tries to touch 0 but never gets to touch 0, so it's y greater than 0 or from 0 to infinity. The behavior, let's take a look. So as x increases, y increases, because as x gets bigger, y gets bigger. The y-intercept, so when x is 0, y is 5. Now for the next one, let's actually try graphing this guy first before we take a look at anything. Well, I guess one thing we could do is determine what kind of, is this a growth or decay function? Since b is less than 1, but it's greater than 0, this is going to have to be a decay function, so this function is going to get smaller. So let's start putting these values in so we can get them. So 2 times 0.68, 2 and -2. 4.33. 4.33. 1. 2.94. 0 is going to be 2. As you can tell, the values are getting smaller. 1, 1.36. And then last but not least, 2. 0.9248 or 0.92. Let's take a look at -2, -2, -2, -2, 4, and a third. You know, like right here, -1, 2.94. Out here-ish. 0, 1, about here-ish. And then 2.92 here-ish. And now we connect the dots. And remember the general shape of our graph. So this graph starts at a high number, so it's actually no, this graph, it uses all the x values, so it's all real numbers. Or from negative infinity to infinity. The range is y is greater than 0 because it doesn't ever cross the x-axis. Or you could say it goes from, 0 to infinity, even though you start, from a big number and then it decreases. You go in order when you write something like this. And the end, or the behavior is as x increases, y decreases. Because, the x values get bigger, the y values get smaller. The y-intercept, when x is 0, y is 2. All right, next set of problems to do. So that was example 2. Number 2, which will be example 3, 4, and 5. Identify each function as exponential growth or decay. State the initial amount, growth or decay rate, and growth or decay factor. So the first function we're going to look at would be example 3. And we'll look at A. So is this going to be growth or decay? Remember, to determine if something is growth or decay, it is y equals A times b to the x. B is greater than 1 for growth. B is greater than 0 but less than 1 for decay. So I look at my B value, it's greater than 1. B is greater than 1, so this is growth. My A value is going to be my initial. So right here is my initial. So my initial amount is 3/4 or 75 hundredths. My rate, because remember, B equals 1 plus or minus, plus for growth, minus for decay. So my rate is my R value. And since I have a growth function, it's going to be 1 plus R. So for here, it's going to be the 1 plus the 0.85. So my rate is 0.85. And my growth factor is the entire thing, which would be 1.85. Growth and decay, for that one. B, y equals 4 times 0.7 raised to the x. So I want to take a look at my B value. B is less than 1, so I have decay. My starting amount is the number in front of my B value, so this is my A value, so my starting amount is 4. Since this is a decay function, it's going to be 1 minus R equals 0.7. Subtract 1 from both sides. Negative R equals negative 0.3. Divide both sides by negative 1. R equals 0.3. So my rate is 3/10. My decay factor is going to be 7/10 or 0.7. Last one, f of x equals 165 times the quantity 5 halves to the x power, or raised to the x. So I know that 5 halves is greater than 1, so I know I have a growth function. My starting amount is the number that's in front of my function. So my starting amount is going to be 165. My rate is going to be the number added to 1. So 1 plus r equals 5 halves. If I subtract 1 from both sides, I get r equals 5/2 minus 2/2. My rate will be 3 halves because that's how much it's increased by, and how much it increases by each time is my growth factor, or decreases by is my decay factor, which will be 5 halves. If you have any questions, comments, or concerns, please don't hesitate to ask. The link to the, hope you have a beautiful and wonderful day, and Mr. Othman is out. Have a great one.